So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? You can all use the questions and the chat window, guys, to give me a quick information if you all can see my screen and hear me loud and clear as well. You can all use the questions tab. Wonderful. Thank you for the confirmation, Chaitanya. Again, webinar registrants. Perfect. Thank you so much for the confirmation, guys. Sampath, Jay, Ashraj, Selvaraj, Amir, Faisal, Ruchikar, Akhil. Perfect. Thank you so much for the confirmation, everyone. So let me start by introducing myself. So my name is Neeraj Keria, and I've been working in this IT industry for almost 10 years now. We have worked in different industry verticals, including insurance, banking, retail, pharmaceutical, aviation, location-based services, and satellite imagery in the markets of India, US, Canada, Singapore, Australia, and other Southeast Asian markets so far. And in the training front, I have been actively working as a corporate trainer. We have trained the workforce of companies including Accenture, EY, Mercedes, Capgemini, Adobe, Google, Crab. So I've been working on training the workforce of these companies and making sure they all are updated in the current trends and technologies so that they can deliver a more optimal solution to the clientele, because we know in this highly competitive world, we have to stay a step ahead to a competition, right? And that's exactly what I have been helping these companies in achieving that. All right, so now let's get started. Now, before we start with the session here, guys, so let me share something interesting with you all. So we have our own meetup community. So let me share this link with you all. So here we have our own meetup community where we organize 100 plus webinars in every month, ranging on different topics, including cloud computing, on AWS, Azure, on the development using Python, using the web development, DevOps strategies. So there are multiple topics, and there are 100 plus webinars that we conduct each and every month out there, right? So first of all, let me share this link with everyone so that you all can have the link to the meetup. So meetup is a really interesting community that we can join, and again we can have the access to all of those webinars completely free of cost, right? So this will be a good learning path, you all, in a good platform to get understanding on what exactly is happening in these technologies as in 2019. And again, the best part of it, it is completely free of cost, right? So let me share this link with everyone. Here you go. So there are more than 11,000 members who are already a part of this entire meetup. And here we can see we have multiple events that we conduct on a daily basis, right? So these webinars, again, you can have a one-to-one interaction with the trainer as well to understand, to have a better clarity on the topics that you want on, correct? So here we can join this community, and again, we can be notified on every webinar that we would be organizing as a part of this entire meetup. All right. Perfect. So now let's get started. So today we have gathered to discuss on the introduction of DevOps. So here we'll be understanding what exactly DevOps is, what are different tools and technologies inside DevOps, and how we can get started, right? So the main agenda for today's session would be why DevOps, why exactly we need DevOps, what is DevOps, what are different components and what are different phases involved in DevOps, what are different phases, or we can say stages, available in DevOps, what are the most popular tools available in DevOps, and what are different use cases for DevOps, where DevOps is currently implemented, right? And how exactly it is impacting that particular industry vertical, right? And there's a simple single rule that we have to follow for this entire session here, guys. In case you have any questions, any doubts, please feel free to drop in your questions directly in the questions tab without any hesitation, without raising hands, without asking if you can ask questions, right? So in case we are discussing on any topic, you are stuck at that point, please feel free to drop in your questions directly in the questions tab, so that once I have seen those questions, I can make sure to answer them one by one, right? And again, a second pointer, since we have a good number of participants joining in, it may happen that sometimes some of your queries may be buried in the pile of questions that we will be getting, right? So in case that happens, do not feel disheartened and continue to post your questions again and again until unless those are answered once I have the visibility of the same. All right, so now let's get started. So earlier, when we talk about the development process, then there were multiple development models that we used to follow, right? That we used to follow here. Like we have now the earliest one that we are familiar with is the waterfall model. So waterfall was basically the initial level, or the initial phase of development that we had followed, right? So the main in waterfall model, we had multiple phases or multiple stages, as we can see here, starting from gathering the requirement, then we had design, then we moved on to implementation, as in the actual coding phase where the entire development took place, and then we had the testing, then we had the deployment, and then we had maintenance as a part of the entire waterfall model, right? Now this was all structured with a definite timeline attached to each and every phases here. For example, suppose if we talk about the design phase here, suppose if we talk about the design phase, now if we talk about design phase, and then it was specific that suppose if we had given a timeline or to design phase, suppose as 1st of November, right? And now based on this timeline itself, if we have specified this as 1st of November, then same way we have for the development part, we have defined the timeline that this would be ending by suppose 1st of Jan, right? That was the timeline for implementation, or we can say development, right? Same way for testing, we had defined the timeline, suppose for 15th of Jan, and same way for deployment, we had planned for 30th, and so on, right? So suppose if we want to roll back to any of the previous phases here, then again, that was a challenge. Why? Because if we make changes to any particular phase here, all the subsequent phases would have to change, right? And that was a complete limitation available in waterfall, right? So although waterfall model was good for small scale projects, but again for mid to big level projects, again this was completely a failure at that level, right? And since now to remove these kind of drawbacks, as we have seen here, so again there was no working software produced until the late of the cycle. That means suppose if we want to revert, if we want to implement some of the changes here, right, then obviously we have to wait for the entire phases to complete, and then only we can come back and apply those changes, or again we have to again wait for the entire deployment to even test it out, right? So the entire process was lengthy and time consuming. And suppose if we have been reported a bug today, and suppose if we get the feedback of how that fix was recepted, right? Then again, if we had to wait for a month or two to get that feedback, again, then we have already lost in the market, right? And again, that's why this created a high amount of risk as compared to anything else, right? So again, this created a high amount of risk as compared to anything else, right? And this was exactly not a good model for complex, because if we are working on big scale application, that means we have multiple risks involved, and using this model, then we are bound to fail if we apply this for big scale models, right? And that was a main limitation for waterfall. All right. And then to solve the waterfall model issues, then we came up with agile methodology. So agile was also derived from the waterfall. But what agile changed, agile simply made the process of design, development, and again producing the first iteration possible within the entire model itself, right? So not all the phases, like we had the deployment and the testing phase. So again, that was again in the same sequential format. But if we want to divide the entire project into multiple smaller segments, right, then we can design and develop, and then we can make changes to that in a continuous manner, right? And that's why the entire duration of delivery was again broken into smaller parts, and that's actually improvise the delivery module here, right? So if we compare this with the waterfall model, then in waterfall everything was sequential. That means until as we are done with design, we cannot go back to planning here. Unless we are done with build, we cannot go back to design here, right? And again, if you want to revisit design here, then we have to wait for the entire pipeline, entire model to be completed. Then only we could have come back, right? Whereas in Agile, analyzing, planning, and deployment is still in the same sequential format, but the design, building, and testing again can be broken down into smaller parts, and then they can be finalized individually. We can do that easily, as we can see here. All right. Now, coming back to again now limitations of Agile. Now, this is the most popular scenario, most popular and common scenario in every possible corporate out there, right? So first of all, let's say we have a development team out there, right? Now, developers, they always want the change, and the operations team wants the stability, right? Now, the development team, for example, let's understand this by a simple use case here. By a simple use case, for example, let's say here we have something. Suppose, let's say here we have a small code. Now, suppose development team out there, they simply build a code on top of Java, right? Now, they have built this code on Java, but they have built this on, suppose, on 1.8, right? Now they have tested the application as well. That means now this entire code is again developed on 1.8, and this is working smoothly without facing any kind of possible errors, right? Now they passed on this code to the operations team for testing and deployment. And now operations team also use the same code. They didn't make any changes to the code here, but a simple and small change is they are running this code on top of Java, suppose 1.6, right? Now, since there's a difference in the versions of Java we can see here, then this will create a simple error. But that means now whenever operations team is trying to run this code here, they will find this error, right? So again, they will simply blame the operations team that they have given them a broken code, right? Whereas the development team can, if when they will revisit the entire code here, they will find no problem at all, because they have the correct environment, they have the correct code, right? So problem is the miscommunication and misconfiguration between these two, right? And that actually creates a civil war between development and the operations team out there, right? And that's why we have DevOps. So DevOps is simply the combination of these two, development and operation scenario here, right? So DevOps is simply the combination of all the development team, all the jobs taken by development team, and combining them together with the operations team, so that the possibility of having a civil war is almost, we can say, leads to none as compared in the real-time development scenario here. All right. Now, when we talk about DevOps, when we talk about DevOps here, now DevOps is divided into 8 main modules, as we can observe here. So first of all, here we have the planning, the coding phase, the building, the testing phase. Then we have integration. Then we have deployment, operation, and the monitoring phase available out here, right? That's a part of DevOps that we can observe. Now, in DevOps, now first of all, here we have something as the planning phase. Now, in planning and coding, this part is called as continuous development phase here, right? So these two strategies are called as continuous development. Now, in planning phase, first of all, whenever we are starting any project, obviously we have to work on making sure that the entire planning is done properly for the project, right? Because before we start doing anything, obviously we need a good planning. We need to have a structured planning of what kind of tools we will be working on, what will be the timeline, how the entire project has to be segregated, what should be the timeline, and every possible scenario out there, right? And first of all, that's why we have the in the planning phase here, we have tools like we have Trello, right? Now in the planning phase, we can use tools like we have Trello to help us in planning phase here, right? So now in planning, we can use the popular tools that we have Trello that we can use. Now, next is as a part of the coding, phase here. Thank you for your appreciation, Sanjay. And as a part of the coding phase here, now here we can understand, now in coding phase, we have multiple tools to work with. Like we have Git, we have SVN, and then we have Jira, right? So now in coding phase, first of all, let's say where we have a concept of source code management, right? So we need to have a source code management through which we can manage the entire code being submitted to us by our development team that is spread out throughout the entire globe in remote positions, right? Now, when we are talking about SCM, a source code management, then exactly what it means, for example, to understand this in simple layman terms here, let's go back to our Picasso mode. Just a moment. Let's open this up. Now, here, if we are talking about something as SC and source code management, right? Suppose, let's first of all understand what this is. Suppose if we have a team of developers, suppose one team is sitting in Seattle, the other team is sitting in, suppose in Johannesburg, the other team is sitting in, suppose in Mumbai, the other team is sitting in, suppose in Sydney, and the other team is sitting in Tokyo, right? Now, suppose all of these team members, they all are working on the same code on the same website, right? Now, suppose there's a manager here. Now, instead of sending codes back and forth to the manager, right? And again, it will be a difficult task even for the manager to keep a track record of what kind of changes and how many files have been sent to them as a part of the entire team project, right? Now, just to make this entire setup here more structured, what we do, each and every developer they can have the access to something called as the remote repository, remote or central repository here, right? So that each and every developer, they can simply submit this code into a central repository here, so that it becomes easier. For example, suppose a manager wants to know or wants to see the files committed by each and every developer, right? So instead of asking each and every developer from one by one, the manager here they can simply refer to the central repository, and they can know what kind of file has been submitted and by which user and at what time and what are different versions for it, right? That is a main rule of a source code management. And then we have multiple tools out there, right? Like we have Bitbucket, we have the GitHub as a part of source code, as a part of remote repository. All right. Now, same way, now if we come back, let's suppose if we erase this part here, okay, webinar resistance. So please solve my problem. Audio is not playing. Sure. So you can contact the support team here, webinar resistance. So, or you can just try refreshing your audio network to solve the AV issue. Here you go. All right. Now, same way, if we come back here now in the coding phase here, now there are multiple tools that we can also use as a part of version control system, right? Now, when we talk about version control system, let's understand first of all of what exactly version control system is, so that we can have a better understanding. Now, when we talk about version control system, now, for example, let's say if we have built a website. Now, in this website, here we have a tag. Suppose here we have, first of all, here we have H1, then we have H2, then we have, now this is the first version that we had developed. Now the client came back to us, and now the client shared us, now have a different requirement, right? So here we have, suppose now the client asks us to first of all put H2 in the top section. Now we have the paragraph, and now we have now this is the second version out there. Now after a while, again the client came back to us. Now they want division on top here. Now they want first of all a division on top. Then they want the H2 tag, and then they want a simple image as well as a part of the entire project here, right? So what we did, we simply saved this as a third version. Again, client came back to us. Now they want image on top, then followed by a paragraph. So this is what they want. Will be the fourth version, right? Same way they can keep on asking for n number of changes. Same way they can keep asking for n number of changes here, right? And now, if we are focusing on n number of changes now, suppose after 20 changes, the client came back to us, and now they want to restore to the second version here, right? So now if we have the copy of the code that we have changed, that we have developed as a second version, then it is much easier for us to restore back this to the second version out here, right? But if we have not maintained any copies here, then it will be really hard for us to do that, right? Again, we have to sit down, again we have to recode it, again we have to make the changes here, right? Again, and we may not even remember what we had done in the second version, correct? And suppose even after we did revert to the second version here, again client came back to us. Again they asked for restoring to the suppose the ninth version, right? Again we had to sit down and code the ninth version change there, right? And that's why it will create we can say a major problem for the development team out there, right? And that's why we need to make a version of each and every changes that we are making on the entire code structure here. And this itself is called as a VCS, as a part of version control system out there, right? So first of all, are we all clear on the concept of version control system? Please give me a quick confirmation, everyone. Are we all clear on the concept of version control system, everyone? Please give me a quick information, guys. Bhanu, Bharat, Chaitanya, Damodar, Nathan, Ravi, Sampath, Praveen, multiple webinar registrants, Shilpi, Pramod, Samuel, Harshit, Vandana, Sumit, Pavani, Kala, Kamal. Perfect. Thank you so much for the confirmation, everyone. All right. Perfect. Thank you for confirmation. Now, here we have something as, let's first of all, let's erase this up. Now, in version control system, here we also have something as centralized version control system, and then we have distributed, right? First of all, let's see what exactly centralized version control system is, right? So now when we are talking about centralized version control system, let's say we have 5 developers out there. We have developer 1, 2, 3, 4, and 5. We have 5 developers out here. Now here, each and every of those 5 developers can be working on their workspaces, right? Suppose here we can have the first, second, third, fourth, and fifth developer out there, right? Now they all can now, each and every development team here out here, as a part of source code management, what they can do, they can continuously push whatever changes they have made in the entire code here. They can commit it directly to the central, or we can say central or remote repository, right? Central or remote repository here. Suppose the same way one can commit the changes to the central repository here, same way 2 can do it, same way 3, 4, and 5. Once they all are done with their making changes in their version, they can all commit their codes to a central place, a central server called as central or remote repository, right? Now this is a part. Now when each and every system here is connected directly to a central system or a central repository, then this is called as a central version control system out here, right? And after central control version system, then we have something as VCS, distributed version control system. But here what we have is, here we have attached something as local repository as well with each and every system before it can commit the changes directly to a central repository. That's why we have something as local repository here, as a local repository, as a part of local repository here. Now when you say local repository, now suppose initially if this would have been okay, Sanjay, so can you explain again? Shashank, okay, sure, let's do that. So first of all, now in central version control system, what we have is, in VCS, what we have is, suppose if we have multiple systems connected here. Now what we can do is, we can have multiple systems, they can all continue to commit, or we can say push their changes in the files that they are doing in a central location here, right? So whatever changes they are making in the file here, they can all save the changes, they can all commit and push the changes to a central location, or we can say central repository, right? Whereas in distributed version control system, what happens before they can commit directly to a remote repository? First of all, each and every system has to commit to a local repository here, right? And this will be part of the same system. Suppose there are 5 different changes made on the same file here, right? So those 5 different changes can be committed in the local repository, and then local repository can commit a single change. That means the final file which has been changed here to the remote repository, right? So that we can maintain a much cleaner look and much more distributed and centralized version here as compared to the centralized version control system out here, right? And that's why we had distributed version control system. And even in this case, suppose for some reason the remote repository server is not currently available, it is broken or not available at some point of time, right? Then system can still continue to work on their own. They can still continue to commit changes to the local repository, and whenever the remote repository is available, the same changes can be pushed to the remote repository as well, as a part of advantage over centralized version control system out here. All right, so are we all clear on the concept of centralized version control system and distributed? Please give me a quick confirmation, guys. Are we all clear on the concept of centralized version control system and distributed version control system out here? Arun, Akin, webinar registrants, Anish. Pramod, Jaskirat, Shilpi, Kevin. Sure, Matthew, Sandeep. Kamal, wonderful. Thank you so much for the confirmation, everyone. So now let's erase this out. All right. And that's why here in the continuous development phase here, okay, so planning tool, so we have nothing about the planning tool Trello. So we are currently structuring, because the most important topic here is the continuous development as a part of the source code management. Then we have the continuous building, testing, integration, deployment, operation, and monitoring, right? Because as a part of the main job scenario, or we can say job profile of a DevOps, the main focus lies on these different platforms more than the planning phase. But again, in case of you need any kind of help on even planning, then I'll be more than happy to share documentation for the same with you. Sounds good, Suji? Please give me a quick confirmation. Okay, yes, definitely. We don't need to know. We don't want to, but again, we don't need to know. That's the case. Is it clear now, Suji? Perfect. Thank you for confirming. And that's why in the continuous development phase here, we have tools like we have Git, we have SVN, we have Jira, where SVN is a simple example of the centralized version control, whereas Git is a small example for distributed version control system, where Git is the most popular tool available out there as a source code management tool out here, right? So Git is almost 3 to 4 times more popular than any other tool available as a part of version control system. All right. Next is once we are done maintaining the different versions of the code here, then obviously once we have the code created, once we have the code coded, then we obviously need a tool to create a build out of it, right? And that's why for continuous building, we have tools like we have Mavens, Apache, and then we have Gradle, right? So Mavens is basically used as the most popular tool available for creating a build out of it. For example, suppose we have built something on top of Java, right, on the Java code here, right? So obviously we need a tool that we have Mavens to create a build out of that particular Java code, right? And now once we have the code, once we have the build created, then we move on to the testing phase, where the most popular tool for testing is Selenium. Now, what exactly Selenium is? Selenium is the most popular testing script platform, because using Selenium, we can using Selenium we can add multiple testing scripts here. When we say testing scripts, for example, suppose here we are testing one particular module out of this entire web page here, right? So what we can do, just to test this particular module, we can create a simple testing script. This can be done in Python as well, right? So we can create a small testing script, and then we can test then we can test the then we can test this module here, whatever we want to be tested, and then we can see the output, right? So svn basically has multiple svn basically has Selenium basically has multiple output as a part of log, right? And that's why we have tools. That's why we have tools here called JUnit. So JUnit provides a complete dashboard, right? So suppose if you don't want to see logs, we don't want to see and share logs as a part of results, then we can use tools that we have JUnit, where we can see the result of testing as a part of web dashboard as well. And that's why we have tools like we have JUnit, right? And that's what the continuous development, building, and the testing phase here, right? Now, then we have the platform, then we have the tools here as continuous integration. So continuous integration sets at the core, or we can say heart of the entire DevOps strategy here, right? Because continuous integration, now in continuous integration, we have tools like we have Bamboo, we have Hudson, we have Jenkins, where Jenkins is the most popular tool out there for continuous integration, right? Now, why Jenkins? Now, first of all, why is that? What exactly we mean by continuous integration? Now, in using continuous integration, we can create something like we can automate each and every process here as a part of DevOps, right? So using continuous integration, what we can do, we can create something as a pipeline through which now we can, first of all, here we can define suppose the code here. Suppose as soon as the code is available, suppose there are multiple developers working on the codes, and as soon as any of them has made some changes to the same code, then the code can be fetched directly from from Jenkins as a part of continuous integration, right? And once the code has been fetched, suppose they are now currently today in the morning we have a new fresh code, a new fresh copy of the, or we can say the latest version of the code available, right? So this code can automatically be pulled from the repository, and then it can and then a continuous build can be created out of that particular code, right? Automatically. Once that build is ready, then the same now the testing script that we have pre-written, they can be applied automatically to the build that we have currently created, and this entire build can be deployed to multiple servers or here as well, whether production, staging, or the testing environment, so that we can see the feedback for the same and send it back to the coding team, right? So these all things can be structured as a timeline, and these all things can be automated without any human intervention in between, apart from keeping a check or apart from quality control, right? So these all things can be automated by a continuous integration tool called Jenkins, where Jenkins is the most popular tool for the same. All right. Now, next is we have something as deployment. First of all, let's clear this out. Now, next we have something as deployment here. Now, in deployment, what we do, we simply pass on the code to the deployment. We simply pass on the code to the deployment here. Now, why exactly we need to deploy? Let's understand this through a simple example. Suppose here we have a coder. Right? And then here we have the operations management team. Now, the coder, they simply share the code in Java, right? And they share the code the same with operations team itself, right? Now, but because the coders are using Java 1.8 and the operations team is using 1.6, right? So obviously they have to upgrade in order to make this entire code compatible, right? So instead of sharing just code, what they can do now, what coders can do, they can simply create a container of that code that contains not only the code itself, but all the libraries and all the dependencies for it, right? So this entire container can be passed on to anyone, right? So that suppose now once we have the container with the entire image of the application and the coding required, right, all the dependencies, then operations team can, without any worry, they can simply deploy this code into their own platform using the containers or using the Docker itself, right? So that they don't have to worry about the mismatch in the environment and the code that they have shared, right? And that is why we use the tools like we have Docker and as a most popular containerization tool available here. That's the main concept of containerization, why we do it, and what's the outcome of it, right? And that's why we have the most popular tool available for the same, for creating those containers, and that is Docker. All right. So are we all clear on the concept and the purpose of using containerization tool? Please give me a quick confirmation, everyone. Are we all clear on the concept of containerization and why we need it? If you all can give me a quick information, guys, I can make sure I can be sure that this is completely clear for all. Sumit, we are good. Okay, Sai, so can you quickly repeat? Shilpi Sinha, Harshit, clear? Samuel, perfect. Sumit, what goes into container? Okay, thank you for the confirmation, guys. Now let's do one thing. Let's have a quick recap. Let's have a quick recap for the same to have a quick understanding on the same subject. Let's erase this all. Now, for example, suppose here we have a coder. Here we have the coder available here. Here we have a coder, right? Now, and then here we have the operations team. Here we have the operations team available, right? Now the coders they have developed something on top of Java file here, right? Now they have the coders they are running suppose Java 1.8 and the operations team they are running on 1.6 itself, right? Now if coders they share this Java file with the operations team, obviously there will be multiple setbacks. There will be multiple compatibility issues. So the same code will not properly function in operations team environment. Why? Because they don't have the correct environment in place to properly execute this piece of code. Correct? Are we clear to this part? Shilpi, Santi, Hitesh, Shahrukh, are we clear till this point? Please give me a quick information, everyone. Sumit. So obviously, suppose if when they are sharing the code here, obviously they will not be sharing. They will be sharing this code here. And again, once they share the code, this will obviously create multiple compatibility issues, right? Because both of them are working on different versions of Java here, right? And just to save, just to make sure that this compatibility issue does not break it up. This compatibility issue does not break it up. What they can do, instead of just sharing the code alone, what they can do, they can simply create a container out of it. Now, in this container, they can not only contain the entire code, but they can also contain all the libraries and all the dependencies for running this entire code here, including the correct version and all the libraries that is required for Java, right? Suppose again, and that's why if we talk about containers here, containers are simply containers. They contain the images that contains all the configuration and all the dependencies that is required to run the code properly, right? So again, what they can do, they can without any worry, what they can do, they can now share the entire container with the operations team, so that now the operations team they can run this entire container using Docker, right? So using a simple containerization tool available, that is Docker, right? So that they don't have to even worry about getting a broken code, because they'll be using the same environment which has been shared by the developers, which is currently working. All right. So is it clear now, everyone? Please give me a quick information, guys. Are we clear on this part? Shilpi, Harshit, Sai, Santi, Sumit, Arjun, Arun, Anken, Wonderful. Thank you so much for the confirmation, everyone. All right. So now let's erase this up. Yes, Arun, they can simply share the containers out of it, and again, this entire images can be shared among different team members. They can share that. Is it clear now, Arun? Perfect. Thank you for confirming. So now let's erase this up, and now let's move ahead. And then we have, and then for if you move in the operations phase here, then we have something as continuous integration. We can say configuration management tools available, right? And as a part of the most popular configuration management tools, we have Chef, we have Puppet, we have Ansible and SaltStack, right? Now, when we talk about the configuration management tools here, now let's understand what exactly the principle is. Now, for example, suppose if we want to configure one particular server with a fixed version of Apache, suppose fixed version of any particular applications, we want to make sure that one particular server is of that particular version itself. There are some CPU restrictions based on the instances or some kind of resources we want to deploy on that particular server itself, right? So these all configurations we can do manually one by one. We can configure these all configurations one by one, or now this is doable. This is now configuring taking care of the configurations one by one is doable if we have a couple of servers, right? But if we want 1,000 servers to deploy it, right, and if we have to take care of the configuration of each and every of those 1,000 servers manually, then that will actually take days for us, right? That will take days for us, right? And just to avoid this complete wastage of resource and time on doing the same configuration again and again for those 1,000 servers, what we can do, we can simply go ahead and use this tool, and again we can use the tool as configuration management tools here, right? Configuration management tools here, right? Like we have Chef, Puppet, or Ansible. So now using these, what we can do, we can simply create a simple template, right? And this template, in this configuration file here, what we can do, we can simply define what exactly needs to be configured, how we have to configure it, right? And the same configuration file will be used for configuring 1,000 servers, and that too not sequentially but parallelly, right? So suppose if 1,000 servers configuration would have taken suppose let's say 2 weeks to configure properly, right? Then using the configuration management tools, we can do this within minutes or max to max an hour itself, right? That's what exactly we mean by configuration management tools. And that's why we have tools like we have Chef, Puppet, Ansible. These are the most popular configuration management tool that we will be focusing on. All right. And after configuration management tools here, we have something as monitoring tools. So monitoring tools are basically, now when we talk about monitoring tools here we have something as continuous monitoring. Now, when we are talking about the complete DevOps, obviously we need a platform, we need the tools to make sure that each and every phase is available in DevOps. They all are working fine without any kind of issues out there, right? For example, suppose there's a breakdown in Mavens. Now, Mavens is not working properly for building. Selenium is not working properly for the testing purposes here, right? So if any tool is not working properly, then that can be monitored on a continuous manner using these tools, right? Using the tools of continuous monitoring as a part of DevOps, right? And that's why we have tools here like we have Splunk, we have Nagios, we have Stack, where Nagios is the most popular tool available for continuous monitoring here. Nagios is the most popular tool for continuous monitoring. Why? Because Nagios has a good dashboard, it has a good UI dashboard, which can be used to visualize and keep a check on the health status for each and every process out there, right? And that's why Nagios is the most popular tool as a part of continuous monitoring. All right. So this is the complete, and again, as we can see, there are almost more than 100 plus tools available for each and every platform in total, right? As a part of DevOps, right? Now, when we are on DevOps, We don't need to have a good understanding on each and every, on all those hundreds of tools out there. That won't be practically possible and feasible for everyone, for anyone, correct? So here what we can do, here we need to have the expertise only selective tools in each and every phase here. Then we are, if we have those expertise in the selective tools in each and every phase here, then we are good to go to call ourselves a DevOps engineer. Right? So suppose if we are now in continuous development, if we are good with the knowledge of Git, it's more than enough. In building, if we are good with the knowledge of Mavens, we are good. If we in continuous testing phase, if we have the knowledge or good understanding of Selenium, it's more than enough. If in integration we have a good command over Jenkins, that's more than enough. In deployment, we need to know Docker. In operations, we can know either Chef or Puppet, and in monitoring, we can know Nagios. If we have the good expertise and good knowledge on these tools, then it is more than enough to call ourselves a DevOps engineer instead of having the knowledge of each and every tool out there. All right, and that's why we have these things combined as a part of our continuous DevOps strategy. All right. Yes, Ravi, this is going to be a series of class, and this is the first out of the entire series on DevOps that we'll be conducting. Is it clear, Ravi? So in each and every session here, we'll be focusing on different modules one by one. Perfect. Thank you for the confirmation. Now let's move ahead. And that's what we had discussed here. Here we have main 4 phases. Here we have first of all, the version control system that we had discussed on source code management. Then we had discussed on continuous integration using the continuous build, where we can we simply first of all compile, validate, and again we perform the entire integration testing for the entire code. And then in continuous delivery, we simply make sure that we are continuously testing and attaching the test scripts and deploying on the servers as a part of continuous deployment, right? And each and every of these phases are continuously monitored using tools that we discussed. Continuous monitoring tool that we have Nagios and Splunk, where Nagios is the most popular tool out there, right? Then we had discussed on source code management. We had discussed there are basically 2 types of source code management. We had discussed on centralized version control system. So uncentralized is a single central repository where each and every working copy, or we can say workstations, they all continuously submit the codes. They all continuously commit the codes to a central location itself, right? And in distributed, first of all, they commit each and every workstation out here. They first of all commit the code to a local repository, and then only it gets committed to the central repository here. So that in any case, even if the central repository is not available, developers, they can continuously work on pushing the code to the central or to the local repository, which is not the case in centralized, right? And this is more structured. This can be used for the large scale projects, but again, centralized is a complete failure in the large scale projects, right? And that's why Git is the most popular tool, most popular source code management tool. Why? Because Git is a distributed version control system. Whereas if we talk about tools that we have, SVN, so SVN is basically a centralized version control system out there. That's why it's not that popular as compared to Git. And in continuous integration, we had discussed now in the continuous development, there can be multiple team of developers. They all can be committing the codes directly to a central repository. And when we are using Jenkins, Jenkins can simply fetch the code being committed. Suppose, let's say we have developers A, B, and C, right? Suppose here we have developers A, B, and C here, right? So B looks slim here. Let's make it fat. Right? So suppose here we have A, B, C here. So suppose, but as soon as A has committed something to this repository here, right? So as soon as there's a change, a commit made by a new change, a new file available in the repository, Jenkins server will automatically fetch that change in by using its own server, right? And as a part of automation, the same code can be sent for continuous building. Now in building, what happens? First of all, the entire code is compiled, then the code is reviewed as well, then we perform multiple unit testing for the code, followed by integration testing, and then we perform the packaging, including the var and jar files, right? That's a whole scenario. That's a whole lot of steps involved in the continuous build, right? And once the continuous building is done, then what we do, we simply move it on to be deployed on the production and testing servers out here, right? So the same code, when it has been pulled here, right, when it has been created, then this can be deployed for the application for the user acceptance test, and this can also be deployed on the production or the staging servers for the testing purposes, right? And for automating the entire task here, that's why we have something as Jenkins as a part of continuous deployment and continuous integration tools here. Continuous tools here, right? And that's why Jenkins is the most popular tool available for continuous testing here. Just a moment. All right, so now let's erase this up. And that's an entire process that we follow as a part of continuous deployment and continuous integration using Jenkins, so that we can automate the entire process that we have discussed of, right? So that's what we had discussed as a part of configuration management tool here. So configuration management simply handles all the changes systematically, so that the entire changes and all the configuration can be done automatically using a configuration management tool here, right? So that the entire servers can be prepared properly as they should be when we're talking about the configuration managements, right? And then we had discussed on the concept of containerization. So now in containers, again, we have a host operating system. On top of it, we have a Docker engine, because here we are focusing on Docker being the most popular tool available for containerization, right? So here, first of all, here we have, now here in containers, we can create, containers can be really lightweight, because why containers are more popular than VM simply refers to virtual machine, right? So when we talk about VMs are too resource intensive, right? If we want to create a VM here, we need to have a good amount of physical resources for doing that, for doing and deploying virtual machines, right? But containers are really lightweight, because again, they do not contain the entire host OS in their own separate entity, right? So here we can create the entire containers, because containers can be created and they can be deployed easily, right? So if we have a system running on Docker, then we can simply fetch that container, and then we can run that container on top of the Docker engine, right? And that's why it is completely lightweight. And that's why it is much easier for any development teams to share the containers as well for the testing and operations phase, right? So that's why we now in virtual here, what we have in virtual machine, first of all, we have the image, and then we have the container here, correct? And in Docker Hub, Docker Hub is simply a remote repository, just like we have a GitHub. Same way we have Docker Hub, where we can store containers, right? And then we can simply send the containers to different staging servers or production servers or staging servers, wherever we need to test them exactly as per the requirement. We can do that. All right. Okay, Sumit, so but OS is required on containers? No, we do not require OS to be packed inside the container here, Sumit. That's the advantage of containers, because if we pack OS as well, again, then it won't be a container, it would be a part of VM, just like we have VMs, virtual machines, right? So is it clear now, Sumit? Please give me a quick confirmation. Sumit from YouTube. All right, and then we have Nagios, and then we have Nagios as a part of continuous monitoring tool here. Okay, Shekhar, so what can be the size of the containers in your description? So again, we can create n number of containers here, Shekhar. All right. Now, next is we have the continuous monitoring tool available. The continuous monitoring we have this we had discussed. Nagio has been the most popular tool out there as a part of continuous monitoring tools, right? So Nagios, what we have here, we have the Nagios process scheduler. So here we have multiple plugins that we can use for monitoring multiple resources, right? And then we can now, and then once we have the entire process, now we have the entire processing done by Nagio server, then we can use plugins to check the status and get results. So suppose if we want to check the status of multiple servers, if they are running or not, right, then we can use the plugins to check the status of those servers. Suppose if a server has been turned off or its server has gone down because of any reason, right, and the current state has been changed from that server from running to the stop state. Again, that can be pushed as a notification using multiple notification services that we have opted for. It can be through our SMS, it can be through emails, it can be through our push notifications. However, we have structured that, right? Suppose and that's what happened in real world use cases as well. So we can, depending upon the requirement of the client and the company, we can create the notification system. Suppose if we have a list of testers, or if we have a list of guys responsible for the continuous monitoring, then we can create a separate notification system for them so that they can be notified for each and every changes happening inside the entire system using a continuous monitoring tool like we have available in Nagios. All right. And that's exactly what happens as a part of continuous monitoring tool available here. Now, as a part of a small hands-on demo, what we can do is let's go ahead and look at the first initial step, and again at the initial level of how exactly the version control system works here, right? Now, for doing that, what we can do, we can start with installation of something as Git, right? Because again, we will be using Git as a part of continuous, or we can say a version control system out here, right? So what we can do, we can simply go ahead and download Git first. So let me show you how we can get started on installation of Git. So here we can simply search for Git bash or Git download. And then here we can click on the first link from gitscm.com. Let me share this link with everyone so that we can all go ahead and download this from the Git website. Here you go. So we can all go ahead and download this link here from the Git website here, guys. So here we have the link available from Git bash. So here we can use this to download. Here we can use this to download here. All right. So now once we have, now this tool is available for all. Now this tool is available for all here. Here we can download this for Mac, for Windows, and for Linux system as well. We can download this for all three platforms. Right. And then we can now, and here what we can do, here we can simply, now once we have downloaded this, what we can do, we can simply get it open. So here we can search for git bash as a part of entire platform. Here we can search for git bash, right? Let's say we open it up. Now, once we have the tool downloaded, let's open it up to see how exactly we can get started on working on Git. So let's maximize this. Now, obviously, this font is too small. It's too big for everyone, right? So now we wouldn't want that much of comfort level, right? So let's do one thing. Let's increase the font size here so that we don't want to strain our eyes, right? So let's improve. So let's increase the font size here. Now, here what we can do here we can simply, now to get started, first of all, we can create a small project, a folder that in which we'll be working on the entire project, right? So here what we can do for doing that, we can simply create a small folder here called with the command as make directory as mkdir, right? So here we can use a command as make directory, and then we can specify the directory name. Suppose we want to call the directory name here as suppose demo1, right? Then we can create a folder as demo1 itself, right? And now once we have already created a directory as demo1, then what we can do, we can simply switch to this folder using the command as cd for changing directory, and then we can specify the directory name in which we want to switch to. So currently we already have the directory demo1 created, and now we can switch to working in this particular directory. So here we can use the command as cd, and then we can use demo1, right? Now, whenever we are working this either on Windows or Mac system, let me showcase you where exactly the folder will be created. So here we can go back to our system here. Now under system here, we have to go to the C section, our root folder, our root account, and under C here we have to locate a folder name as users. Under users, we have to click on our username, and then here we can choose, and here we can see the folder that has been created, right? So here we can simply open the folder, and then under this folder itself, we are working on top of Git here, on top of Git, right? So here, suppose if we want to get started, first of all, here we have to initialize Git using the command as git init, using the command as git init. So now, as you can see here, once we use git init, this will initialize an empty Git repository in this folder that we have currently created, right? So if we go back, here we can see a small folder called .git has already been added into this folder as a part of Git initialization here. All right. So here we can this will be now this is the entire repository, the entire structure for Git that we have initialized in the folder. So now we can get started on working on top of it. All right. So now let's do one thing. Now let's go back. Now let's do one thing. Let's add some files here so that we can start tracking changes on those files, right? So obviously we do need files here, right? So for doing that, what we can do, let's open up an editor here called Sublime. Now we can use any code editors. We can use Sublime, we can use Visual Code Studio, we can use IntelliJ, we can use Eclipse, we can use Notepad++. Any platform will do, whichever we are comfortable with or whichever we have the access to, right? We can use anything here. Now, let's open up a simple editor here. Let's do that. Just a moment. Let's open a simple editor here as Sublime Text. Now here we have simple editor as Sublime Text available to us. Now, first of all, let's do one thing. Let's go ahead and save this file in the folder that we have working on. So here we can move this file to demo1, and here we can save this suppose as home.html. It can be any HTML file that we want to create here, right? So let's save it up. Now here we can get started by creating a small HTML file here. We can use HTML. Then we can open a simple head tag. Under head tag, we can add a small title. We can add a small title here, such as welcome. And here we can close the title. Here we can close the head. As each and every element in HTML needs to be closed as well. There are 90% tags that needs to be open and closed here, right? And then we can open up the body tag. Under body, we want to place everything in center, and we need to have one main headline which can read welcome to Edureka. We can close this up, we can close the center, we can close the body, and finally the HTML, right? Now let's save it up. Let's save it. If we come back to a folder, we can see now we have home.html available in the same folder that we have initialized get in, right? So now if you want to see how this entire file looks like, we can simply double click to open it up. So now this is the entire file that we have currently created. Here we have the title as welcome, and then we have the H1 placed as welcome to Edureka here, right? Now, we want to understand now, we want to track the changes that we are doing to this file here, right? So for doing that, we have to come back to our Git here. Now, whenever we are working on this, whenever we want to make the changes here, first of all, we want to track the changes. We need to use a command called as git add. So using git add, what we do, we add this file to the staging area, Now, what exactly a staging area is? Let's understand that first. Now, for having a good understanding on staging area, so let's open this up. Now, for example, suppose if we are working now, first of all, here we have our workstation or workspace, right? And then then we deploy our code when we commit our code to a local repository, right? And then from local itself, then we commit our code to a remote, or we can say a central repository itself. That's how it works in distributed control version system, right? Version control system. Now, between the workstation and the local repository, what we have is here we have something called as a staging area. Here we have something called as staging area, right? So in staging area, suppose even though we have hundreds of files available in the same workspace. Suppose if you talk about workspace, this entire folder here is called as the workspace or workstation, right? Now we may have hundreds of files in this workspace, but if we want to focus only on one, right? Then what we do, we simply add those files or the current files that we want to be tracked. That means each and every changes happening to those files we need to be tracked. Then we can add them to the staging area. Then we can add them to the staging area here, right? Now, to understand this in a better example here, suppose here we have our own desk, right? Suppose, let's say here we have a desk here. Let's first of all erase this out. All right. Suppose here we have a working desk, right? Now, and here we have multiple files that we have to work on. Here we have a pile of files that we have to work on, right? So what can be these? The pile of these files can be called as the workspace, as called as the workspace here, right? Now, when we are focusing on any file, say what we do, do we start working on each and every file here? No, we do not, right? So in the entire desk as well, we have something called as a working area, right? So here what we do as a part of staging area, right? So what we do, we simply fetch a few files here, suppose one or two papers or one or two files here, and then we start working on those files one by one, right? And once we are done working, making changes to those files here, now what we do, we can simply move, or we can say commit those files to something called as a local repository here. That means these files are now ready to be shifted to a remote location once we are done with that, right? And that's why this entire working space itself is called as the staging area. So are we clear on this part, on the concept of staging area? Please give me a quick confirmation, everyone. Are we all clear on the concept of staging area, guys? Please give me a quick information, guys, so that I can be assured that this is clear for everyone. Perfect. Thank you for the confirmation, Arun, Shekhar, Ankin. Perfect. Thank you for confirming. Okay, Shilpi, so Git init was clear. Staging area, perfect. Thank you for confirmation. Now, so now let's erase all of this up. All right. So now what we had done is we have simply created a separate file, because again, obviously we now as a part of Git, what we are trying to do, we are simply trying to make sure that we are tracking the changes here, right? So what we have done, we have simply created a, now this can be any file here. Suppose this can be any Python file, any Java files, any text files, whichever files that is a part of a project, and we want it to be tracked as a part of version control system here, right? So now if we want to start tracking changes made to this file here, what we can do, we can, first of all, we have to add this file to the staging area in Git, right? So for adding the file to staging area, we have to use this command called git add, and then we can use a command as, and then we have to specify the file. That means which file we want to add here. Currently we have home.html, right? Suppose there were multiple files in the same document, then we could have mentioned the exact file that we want to add. Okay, CG, so what software are you using for Git? We are using Git Bash. We are using Git Bash, CG. Let me share the entire link with you again. Here you go. So we are using Git Bash for our demo here. Is it clear now, CG? All right, so now once we want to add this, now we can simply use a command as git add, and now this file will be added to the staging area, right? So now what we can do now to start, now this file is now being tracked by Git for any change made on the file here, right? So now let's do one thing. Let's add another h2 in the same file. Let's name this as we are learning Git. Then we can simply close the tag here. Let's save it up. Now what we have done, we have made a change in the file, correct? So now let's save this up. We can come back. Now for knowing the differences, like what kind of change we have made and what kind of change has been tracked by Git, we can use a command called as git difference, right? And when we use get difference here, get diff, then we can see the changes here, correct? So this was, now here we had different versions available to us, A and B. And now this was the earlier version. Now in the second change, what exactly has changed? That will be highlighted and recorded by Git as a part of version control system out here. So as you can see here, now this is what we had added after adding this to the staging area. And now this can be seen as being tracked by Git, right? Again, if we make some changes here, suppose, let's say we remove this file, we remove this line, and we add something as, suppose, a simple paragraph. Suppose we mention the date today, October 14, 2019. We close the paragraph. Again, we save it. Again, we come back. Again, we use git diff. What we can see here we can see the changes here being tracked by Git itself. Is it clear now, everyone, how to use Git till this point and how to see the differences being made on the file? Please give me a quick confirmation, everyone. Please give me a quick confirmation, guys. Is this part clear to everyone until this point? Akin, Arun, Anish, Sumit. No, Sujit, so we don't need to know bash scripting for this. We don't need that. So are we all clear till this part, everyone? Please give me a quick confirmation, guys. Pratima, Matthew, Trishit. Sumit, Kamal, Yukti, Sean. Okay, what are the other ways to practice Git that we will be discussing, Shri, as we continue ahead with our subsequent sessions, right? Shilpi, Sajanya. Wonderful. Thank you so much for the confirmation, everyone. And that's why here we have the entire, now as a continuation of the journey here, we can simply go roll back, we can simply join the entire DevOps course at our own Edureka, right? So here we have the entire fees, I suppose we have placed the fees as 99.95. Again, here we have focus on 12 different modules. We work on multiple real-time projects, right? Now, to have an entire overview for the entire course here, so here we basically focus on all the 8 modules that we had discussed today. Now for version control, we mainly focus on the tool for Git. For the continuous integration, we focus on Jenkins. For continuous testing, we use Selenium. For containerization tools, we use Docker. And then we have a focus module on Docker ecosystem and networking to understand this in a much better way. For configuration management, we have Puppet, and then we have Ansible. For orchestration, that means for working with a cluster of containers, right? Then we have Kubernetes. For continuous monitoring, we have Nagios, and then we can also get the entire introduction on how we can get started on using DevOps on top of the cloud platform, especially when we are dealing with AWS as a part of Amazon Web Services. Okay, Shiji, so how about Python and Linux? Will that be taught if I enroll for DevOps? No, Shiji. So again, unfortunately, not for learning Python and Linux, we have a separate module out there. But in DevOps, we here will be focusing on multiple DevOps strategy itself and multiple DevOps tools, right? For Python and Linux, we have a separate module that we can enroll for. As a clear, Shiji, please give me a quick confirmation. Yes, Aegis. So again, if we have the understanding of DevOps for Python and Linux, again, it's an advantage for us. But again, these are not mandatory to work on tools for Git and for Jenkins, for continuous monitoring and orchestration part here, right? But again, if you do have the knowledge of these, then again, that will be advantage for us. All right, so I guess we are almost towards the end of the session here, guys. I hope you all enjoyed the last 90 minutes. And again, if you did enjoy, please do rate us excellent in the feedback form. And again, do like this channel here. Do not forget to press like on this entire video for YouTube as well, for those who are watching this from YouTube. And again, please do rate us excellent in the feedback form as a small token of appreciation for the hard work and time that we have put in. All right. So thank you so much for joining, guys, and have a great day. And let's continue discussing on the same and in our subsequent sessions. Thank you so much for joining. You all have been wonderful, and have a great day ahead. Take care. Bye-bye.